Good morning to all of you. I would like to demonstrate another problem, in fact a second order reaction, irreversible reaction using a batch reactor model. In the previous example, we have seen how to simulate a second order reversible reaction and also a first order irreversible reaction. So in this example, we will be dealing with a second order irreversible reaction. The necessary data is given. So let me go back to Aspen, start with a new simulation. So the three components that we have in this problem are allyl alcohol, acetone, and N-propyl propionate. So let us add these components. Allyl alcohol, let us call it as AA, acetone, N-propyl propionate. Let me call it as NPP, N-propyl propionate. So these are the three components we are handling in this problem. So go to the next. So I think you are given with the model that need to be used for property estimation. So let us select that model. NRTL RK. Go to the next input step. Go to simulation environment and create your flow sheet. Again, we are using a simple batch reactor. Connect input and output. So go to the next input step. So I think you are given with this is entering at 30 degrees centigrade and 1 bar. Reactor is also operating at 30 degrees centigrade. 30 degrees centigrade, 1 bar. And you are given with mass flow rates. Acetic acid, allyl alcohol is entering at the rate of 200 grams per second. Acetone, 280 grams per second. Next. So we have addressed stream 1. We may have to give some information with respect to the block. The reactor is operating at a constant temperature of, again, 30 degrees centigrade. And we are assuming that there is no pressure drop. It's a liquid phase reaction. Go to next. New. Say R1. I'll select a general model for kinetics. Next. Stop criteria. 1. Location within the reactor. Variable type, I think we need to get a conversion of 98%. So the variable is conversion. Stock value is 0.98. Component, limiting reactant, acetic acid. Next, we don't have any information about the time, so let me assume some 5 hours. 5 hours, 0.01, about 500 profile points. In fact, you can use a maximum of 1000 points here. So still we have not supplied the kinetic information and the stoichiometry. So it's a second order reaction. So you know the stoichiometry. Allyl alcohol coefficient, stoichiometric coefficient is 1. Acetone, it is also 1. And the product is NPP, N-propyl propionate, whose coefficient is also 1. So we have defined the stoichiometry. Now let us look at the kinetics. So in this problem, unlike the previous two, we are given with A and E. We are not given with the rate constant at 30 degrees centigrade. But once you know the value of A and E, you should be in a position to calculate the value of K at any temperature. So remember this K is given as 2.5 into, sorry, this should be 10 power 7 and E is also 6 into 10 power 7 joules per kilo. So let us provide the 2.5 E7 and E is E7, but the units of E are joules per kilo. And you know, this is first order with respect to both reactants, allyl alcohol and acetone. Right? So we have supplied all the required information here. So we should be in a position to run our problem. So we got to our results. You can look at the stream summary. So 12.4 kilomoles per hour of allyl alcohol is entering. We need to get 98% conversion. That means 0.2% of this should be equal to about 0.2484. Right? This is the amount of allyl alcohol we got. 90% of 12.3967. Right? That should be this. Now, what about the time required for achieving this conversion? So this is the amount of time that we are required to proceed in order to obtain 98% conversion with respect to this reaction. Of course, you can easily check up analytically whether this time that has been calculated by the simulator is matching with your analytical result. Remember, the reaction is second order and the reactants are not in the stoichiometric ratio. So you need to use an appropriate kinetic equation representing conversion as a function of time for this particular second order reaction. And then evaluate what is the time required, because you will be able to calculate the necessary values from the given information. Evaluate analytically and calculate the time required. Compare it with what you have got in this simulation. Thank you.